You have attended all the sessions of electricity?
Yes, sir.
And Harshad is there? Harshad? I can't. Harshad, are you there? Where is Harshad Repa? And why is he not joining? Is Harshad joining for math session? Does anybody know that?
No, sir.
No, sir. Why don't you know your friend, whether your friend is attending or not attending? Who will pay attention to all these things? Fine, कोई बात नहीं. So we started about.
Viraj.
Huh? Electricity. And we said that about the current. What is current? What is current? Quick. Answer fast.
Flow of charges.
Flow of
Flow of-
charges.
That is electric current. That is
Flow of-
electric current. What is current?
Flow.
Force generated by the flow is current. Force generated by the flow is current. So it could be water current, air current, electric current. So force generated by the flow of electric charges was electric current. Just a minute. Just a minute. Just a minute. Then we spoke about electric current, that is rate of flow of charges. Rate means upon time. So charge upon time was current. I is equal to Q upon T. You know why I tell you the same things again and again every day? Because you know this has to be very, very fit into your heads. Compulsory. You should be remembering this. झोपेत जरी विचारलं तर तुम्हाला सांगता आलं पाहिजे लगेच. की what is what? So we said I is equal to Q upon T. So 1 ampere is 1 coulomb upon 1 second, or it is written as coulomb second inverse, unit of ampere. So 1 unit of current, that is 1 ampere of current, is when 1 coulomb of charge flows from one point to another point in 1 second. So then we spoke about ammeter. We also spoke about milliamperes, that is 10 raised to minus 3 amperes. Ammeter is connected in series. Then we spoke about the potential difference is a must. Until and unless there is no potential difference, there cannot be any electric current. And that potential difference V was work done in carrying the charge. So 1 volt is 1 joule per coulomb. Joule coulomb inverse. Then moving ahead, we found a relation using the Ohm's law between V and I, that V was directly proportional to I. So V is equal to IR. This R was called as resistance, opposition to the current. V upon I became R. To measure the potential difference, we need something called as voltmeter. So that voltmeter was connected in series. Series connection I have told you. Common starting point, common ending point.
ते अंडा माझ्यासाठी होतं.
I'm waiting for somebody to finish talking. Adesh, I'm waiting for you to finish your important work at home so that we can concentrate on our less important work of studying physics. Fine. So now that doesn't mean that you should mute and keep on talking at home, all of you. Ridiculous. V upon I becomes R. V upon I becomes R. And then we saw some factors which affect the resistance. So the resistance was, say fast. What was the resistance, children? How was the resistance?
Directly proportional to
Directly
length.
proportional to the length.
I'm asking you, why you all are sitting quietly at your homes, sleeping nicely, donkeys, all of you? This was the first factor. What was the second factor?
Area is inversely proportional to area.
Inversely proportional to
So when we combine, okay, third factor. What was the third factor on which resistance is dependent?
material.
Material. And fourth factor,
Temperature.
Temperature.
temperature. Very good. When you combine these two, what do you get? R is
R
proportional to
proportional length upon area.
Length upon A.
exactly. So R is equal to rho L upon A. Yes or no? Ultimately,
Yes.
RA upon L becomes rho, that is your resistivity. So rho becomes RA upon L. This is one point. Now you tell me current. How should be the proportionality of current?
Directly proportional to area.
Very good. Directly proportional to the area and
Inversely proportional to the length.
Proportional to the
Proportional to
very
length.
good. Inversely proportional to the length. Exact opposite to resistance. So as the length increases, the resistance increases, but the current will decrease. As the area increases, resistance decreases, but the current increases. And we are actually interested in the current. Many a times in the current, many a times in the resistance. So then we also studied a very, very important point, which was that rheostat. What is a rheostat?
Variable resistance.
Yes. So it is a device variable which gives, so variable resistance providing device, I can say. That device, that instrument is called as rheostat. Very, very useful is rheostat. Generally rheostat we don't use in our homes, but rheostat we use in our laboratories. In our physics lab, you will always find a rheostat. In fact, each and every physics experiment related to electricity, you are going to do it with the help of a rheostat, because rheostat gives you variable values of resistances, keeping the voltage constant. Just a second. So that is the rheostat. Then moving ahead, we also saw the resistivity. This resistivity rho is what? What is resistivity? कोई भी घर जाके पढ़ेगा नहीं.
Characteristic.
Nobody. Yes, say, you are right, exactly right.
Characteristic property of metal, of a material.
Exactly. It is the characteristics property. Characteristic property means what? It is specific to the specific material. Every material will have a different type of resistivity. Some materials will have less resistivity, some will have more resistivity, depending. And then using this phenomenon, this characteristic property, we spoke about alloys. What do the alloys have? Less resistivity or more resistivity?
Less resistivity.
More. Alloys
More.
have more resistivity than their constituent metals. Okay. What you are saying is right. Wait, I will explain. I will explain. For example, if I speak about nichrome, nichrome is used as a conductor. Who is a conductor? Who is a conductor?
Which has less
With
resistivity.
less resistance.
Sorry, I had got a call. So what you are saying is right, that conductor material has got a low resistivity. Fine. But this nichrome is made up of two metals, nickel and chromium. Nickel and chromium. And the resistivity of nichrome is more than these two. Now see, an important statement I'm writing. Somewhere in your that resistivity wala part, somewhere you will write down this statement. Very important. Or in your notebook, wherever you want to write the notes, write down this statement, an important one. I'll write like this. Alloys of metals are having comparatively low resistivity. Or let me say having low, which is hence they can be used as conductors. But they have a higher resistivity than their constituent metals. Okay.
Yes, sir.
So yes, you are right that nichrome is a material with a low resistivity. It can be used as a conductor. Just a minute. Alloys we say that are having low resistivities, hence they are used as conductors, but they have a higher resistivity than their constituent metals. And what is one more property of alloys? One more property.
They
What?
don't burn easily.
Very good. Those who have read can answer the questions. Also, they do not burn easily. So these are the two important properties. Hence what?
They have a high melting point.
Yes, and so hence they are used in electrical heating devices. Yes or no? I had told you an important give reason question. Yes or no?
Yes, sir.
Yes, sir.
So till here we have reached with our discussions. Yes or no?
Yes, sir.
Let us continue. Children, we can see Vansh on Friday. On Friday, he'll be coming on screen. He was supposed to come on Monday, but the episodes have got a little bit prolonged. So Friday, you'll be able to see him.
Okay,
Just
sir.
now we are going to start with a very important point, that is resistance and parallel. Before that, let me see if something is remaining. Yes, these examples are in. You see here what I was speaking just now. Nichrome is 100 into 10 raised to minus 6, made up of nickel, chromium, manganese, and iron, that is ferrous. But nickel is 10 raised to minus 8. So 10 raised to minus 6 is always bigger than 10 raised to minus 8. Chromium is also 12.9 into 10 raised to minus 8. It's bigger than chromium also. Manganese 1.84 into minus 6. So 100 is always greater than minus 1.84. And the other one is ferrous, that is iron, 10 into 10 raised to minus 8. So this is raised to minus, always bigger. So this nichrome is definitely bigger than nickel, iron, chromium, all its constituent materials. Do you understand?
Yes, sir.
And yes, one another important, why is tungsten? Tungsten is almost used in as a filament of electric bulbs because it has got a very high melting point. Example 12.3. Now with your pencils in your hand, try to solve it. Don't look at the solutions what they have given. Okay, everybody has the solution, but try to solve it. Just a minute. Okay. How much current? How much current, children? Means what?
I.
I
I
is
is
equal
equal
to
to
what?
question.
Question mark. Immediately, when I read the question in my exam, how much current? I'll underline current. I is equal to question mark for me. Will an electric bulb draw from a 220 volt source? What is this?
V is equal to
Is
220.
equal to
Potential
220 volts.
Potential difference.
V is equal to 220. If the resistance of the bulb is 1200 ohms, what is given?
R.
resistance
Resistance of
R.
And what do we know? V is equal
V is
to
equal to IR.
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 220 is I into 1200. Just solve it. 220 upon 1200 is equal to I. Whatever is your answer, you will get the answer. Yes or no?
yes, sir.
And this is going on for you, not for me. माझ्यासाठी चालू नाहीये यातलं काहीही, तुमच्यासाठी चाललेलं आहे. लिहून घ्या हे, write down and solve it. Don't sit quietly without doing anything. How much current will an electric heater coil draw? Again, how much current?
I is equal to
Arey,
question.
I is equal to question mark.
let this be I1, let this be I2. From a 220 volt source, again V is equal to 220. If the resistance is 100, so R is equal to 100. Yes or no? So again you get I is equal
Yes,
to
sir.
V upon same. I is equal to 220 upon 100. Whatever is the answer. Yes or no?
Yes, sir.
Sir.
Yes, sir.
Yes, sir.
Example 4. The potential difference between the terminals of the electric heater is 60 volts. What is this?
V is equal to
V is
60.
equal to
Equal to
60.
60 volts.
It draws a current of 4 ampere. Acha, and here units. For I, the unit is going to be amperes. Remember, I will always be in amperes. Don't forget to write the correct units. So next here, draws a current of 4 ampere. What should I write here?
I equal to 4 amperes.
What current? Again, now they are asking what current will the heater draw? Means again they are asking I is equal to question mark. If the potential difference is increased to 120 volt, this is V1, I1, I2, V2 is now 120. So using V, how do I find I? Here just now we have found out. How to find I?
V equal to IR.
V is equal to I or I is equal to V upon R. Yes or no?
Yes, sir.
So to find I need V R. Yes or no?
Yes, sir.
Yes, sir.
To find I need V and R. Only V I have. Where do I have the R? Where is the resistance?
Sir, but we know that if 60, the potential difference has increased by certain factor, I will also increase by the same factor.
When will that happen?
Yes, sir.
When the
When will that happen? When I'm speaking about the same
when the
circuit.
resistance is 2.
No. But when it is in the
When the
same circuit.
resistance is same.
Yeah.
When the
But
resistance is same.
no. Listen to me. We had done that activity. Which activity I'll show you? Ohm's law activity. Just a minute. Yes, here. First we connected only one battery, one cell. Then we connected 2. Then we connected 3. Then we connected 4. So in a particular circuit, if the potential difference goes on increasing, keeping the R constant, then the current goes on increasing. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
We had seen some values for V, some values for I, and we saw that V upon I was every time constant. So now, similarly, what is happening, I can see over here, they are saying about an electric heater. Potential difference of an electric heater is 60 volt and current is 4 ampere from the source. And what current will the heater draw? Yes, if the potential, so here the same potential difference. So you can say like that, or else what I will do is that V is equal to IR. So 60 is equal to 4 upon R. This R goes there. R is equal to 4 upon 60. 60 goes there and R goes there and 60 comes here. Don't say 60 upon 4. R becomes 1 upon 15. And now using R and V again, second time. V is equal to IR. Now V is 120. I we have to find R is 1 upon 15. Beta.
Sir, R will be 15, na? Only 15.
R will be
Yes, sir.
15. Yes. Sorry. By mistake, it happened like this. You are right, exactly right. See what is happening. 4 goes there. Just a minute. V is equal to IR, not I upon R. V is equal to IR. 60 is equal to 4 into R. 60 upon 4 is R. So R is 15. And once you get the value of R, put here the value of R. 120 into 15. 15 goes there. 120 upon 15 gives you I, that is 8 amperes. 15 8s are 120. Yes or no?
Yes, sir.
Next, resistance of a metal wire of length 1 meter. So what is given?
Length
is equal to
of the
1
wire.
meter.
L is 26 ohms. What is this?
Resistance
Resistance R equal to 26.
to 26 ohm.
At 20 degrees. Means the temperature is given.
Temperature.
If the diameter of the wire is 0.3 mm, diameter is given. What is given to you? Diameter is 0.3. What is a wire actually, you tell me? Wire is actually a cylindrical shape. Do you know that?
Yes, sir.
Yes, sir.
And the cross section of wire is always a circle. So when I speak about area, I will be speaking about area of a circle. Yes or
Circle.
no? And what is the area of a circle? Pi r square.
Correct.
So when diameter is given to me as 0.3 mm, radius becomes 0.3 upon 2. 0. What? 15 mm. Yes or no, children?
Sir, how?
Huh? 0.3 means 0.30. Yes or no?
Yes, sir.
No. What will be the resistivity? Rho. What is rho equals to? Ra upon L. Is it?
Yes, sir.
Children, are you understanding? Array donkeys. R was proportional to L upon A. So R became equal to rho L upon A. So Ra upon L was rho. Do you remember this? Array donkeys, do you remember this?
Yes, sir.
Is equal to 26. Now this 0.15 mm will be what? 0.15 into 10 raised to minus 3 meters. Yes or no? Radius becomes 0.15 into 10 raised to minus 3 meters, because millimeters is always getting converted into meters. Yes or no?
Yes, sir.
So, just a minute. So now if they are asking us that, so let me rewrite all the things. They have given us radius is 0.3 mm. Sorry,
Sir, it's
diameter.
diameter.
Diameter. They have given us diameter. So radius becomes d upon 2, 0.3 upon 2, which becomes 0.15 mm. And we know that the SI unit is meters. So it becomes 0.15 into 10 raised to minus 3 meters as R. And when I want the area, just now we said for a wire is actually cylindrical in shape. So the area will always be the area of a circle. So area becomes pi r square. If you want, you can write 3.14. Pi is taken as 3.14. 0.15 into 10 raised to minus 3 square. Keep it as it is. Further, they are asking us rho. Resistivity rho is Ra upon L, which becomes now 26 is the resistance. Area we have just now found out 3.14 into 0.15 into 10 raised to minus 3 whole square meters, and then the length is in meters. 1 meter is the length given to us. The length given to us was 1 meter. So this one doesn't make. So now if I solve it, 26 into 3.14, 0.15 ka square. How many?
2.25.
225.
No. Apply your basics. I knew it, you will give me the answer 2.25.
0.0225.
Exactly.
25.
See, 15 square is 225. So when I say 0.15 square, 2 decimals. 2 decimal ka square will be 4 decimals. And I have only 3 digits. So it has to be 0.0225. 4 decimal points. Are you understanding?
Yes, sir.
Yes, sir.
0.0225 and 10 raised to minus 6, because minus 3 square, a raised to m raised to n becomes a raised to mn. And now you multiply these whenever you get the time. If you find out the answer, they have given it in our textbook. After calculations, we get 1.84. The answer of all this is 1.84 into 10 raised to minus 6. And this is what? Resistivity. So what should I write the units? Ohm meter. Yes or no?
Yes, sir.
Yes, sir. Asal, काय आम्हाला करायचंय? Yes or no? Others?
Yes, sir.
Yes.
1.84
Yes, sir.
Yes.
into 10 raised to minus 6. Now, if I consider what they have said, see, find it. Predict the material of the wire using. So we have got 1.84 into 10 raised to minus 6. If I see my table, let me check it is near to which value. Here is my table. And I have exact value over here.
Manganese.
1.84 into 10 raised to. So they are talking about whom?
Manganese.
Manganese.
Manganese. So now I'm going to write final answer statement for myself. Thus, now again I am doing this all because I am a grade 10 student. Okay, I will write all these things. तुम्ही काय लिहू नका बरं का, all of you. You just see what I am doing. Don't even take any screenshots. Don't solve anything. The from table and conclude, or not, I will say using table, not from. Thus, using the table, we can conclude that the given material is manganese. Thus, we using the table, we can conclude that the given material is manganese. Yes or no?
Yes, sir.
Yes, sir.
Yes. Yes.
What? Yes. They have asked us resistivity, and resistivity rho is Ra upon L. Resistance is given, length is given as 1, but diameter is given as 0.3. Using diameter, we first found out the radius. Radius is diameter upon 2. The radius was in millimeters. So we definitely converted into meters. So 10 raised to minus 3. The cross-section area of a wire is always a circle. You can see, you take the wire in your hand, its side area is always a circle. So that area is pi r square. So 3.14 into 0.15 into 10 raised to minus square. And 0.15, 2 decimals square should always be 4 decimals. So 0.0225. So that multiplications, if you do, you get this as the answer. And this is the material manganese. Correct?
Yes.
Yes or no?
Sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now, moving ahead. Now, yeah, 4, 5, these all 4, 5 examples are solved examples in the textbook. Yes or no? And I have also solved it here in the tuition. So now why you will solve again? No need to solve. Yes or no?
Yes.
Yes or no? Or is there a need to solve?
Yes,
Sir, we
sir.
will-
Yes, sir.
Will you solve?
Yes, sir.
Yes, sir.
Fine.
Yes, sir.
Yes, sir.
Now, just a minute, just a minute, just a minute. Now, this is a very, very important question. 12.6. Pranjal, why have you raised your hand? So now, right now, do one
Sir,
thing. Wait. Pranjal, wait for a minute. Less than 1 minute. Every one of you leave the meeting and quickly rejoin. I'll just drink some water and come. You rejoin and stay connected.